So class today, after that knowing all the oxidation number in previous class, oxidation number of phosphorus, knowing the range of oxidation number of phosphorus. Now today we will do the structure of the phosphorus compound. Got it? And with the few questions are there. So let's start with this pH 3 as phosphine. So phosphine is the P is the central atom and 3 hydrogens, so distributed equally like on the side. And I told you that hydrogen can form maximum one bond, isn't it? So just make one bond, one bond, one bond. And phosphorus, now check it, 1 2 3 4 5 6. It must have 8 electrons, isn't it? So at least 8 electrons to hone chahiye. So that 2 electrons will be there is as a lone pair, or we can say that the electron cloud. You make it like this, or you don't, you leave, you can leave also, there's no problem. Okay, like without this cloud you can draw the electron, like lone pair of electrons. Okay, now this is P2H4, the 2 phosphorus are there, so we will arrange it in like this way, and 4 hydrogen. So what we will do, we will equally distribute the hydrogen on both the phosphorus. So 2 hydrogen to this and 2 to this. Yes, as I told you, the phosphorus, that hydrogen will form only single bond, so let it be done. And then 3 bonds is already done, so whatever number of electrons, 1 pair to this and 1 pair to this. To give the stability, I will make the lone pair on the reverse side. Got it? Now this is P4, this is discrete. We have done the white phosphorus. In that case we will do, we have done that white phosphorus, so there we have learned the structure, and the structure is like this. Yes. Now oxo acids, these are the 4 oxo acids. So for oxo acids, I have told you that there must be one electron element double bond O. That means whatever the element is there, if it is oxo acid, whatever the element is there, we are supposed to make at least one element double bond oxygen. Got it? Bond. So let it be P1, so make it like this, and 2 oxygens, so out of that 1 it will form double bond for sure. Okay, after this P4, all this, they will show the expanded valency. That means they will have in the outermost shell, if you will count, you will get that they have 10 electrons. How come? Let's see. Okay, so this is oxygen 1, so let it be like 1, and 3 hydrogen. So what we will do, out of this 3 hydrogen, 1 will be attached with the oxygen and 2 will be directly attached with the phosphorus. So hydrogen form the single bond, so let it be, and oxygen will form either one single bond or 2 single bond or 1 double bond. So hydrogen 1 can make 1 single bond, so I have drawn. Now oxygen, so it has only option to make a single bond, so let it be like that. Got it? So this is the thing. Now if you'll check that phosphorus, you'll see 1 2 3 4 5 6 7 8 9 10. You can say that 10 electrons are there. Actually it is not 10 electrons. Wherever we are drawing this double bond, it is a coordinate bond. In class 11th we have done that coordinate bond formation, and there only I told you that in class 12th it will be converted into the double bond, because 2 electron sharing. So instead of that 2 electron, we will draw the that double bond. Got it? So actually this one is coordinate bond. That oxygen phosphorus will complete its octet by taking 1 from this, 1 from this, 1 from this, isn't it? So this lone pair, one lone pair is left over there, so which it will give it to oxygen to complete the octet of this oxygen. Got it? I hope it is clear. Okay, so now can you make the structure of H3PO3? Same. This is 1 phosphorus, 1 2 oxygen ho gai, and how many oxygen left? 2. So let it be equally distributed. How many hydrogen? 3. So out of this 2, I will give 2 oxygen and 1 directly. Yes? Any problem in this? Now H2PO3. So here it is phosphorus, 1 double bond for sure. And how many oxygen left? 2 oxygen are left, isn't it? So this is 1 and this is 1 oxygen. But how many hydrogen and how many hydrogen are there? So this will form hydrogen over here. It can form. It can go with this like this, and here it will be the lone pair. We can make. Okay. So this is the H2PO3, and now H3PO4. So similarly, we can make P and oxygen. 1 double bond oxygen will be there for sure. How many oxygen left? 3 oxygen are left. So make it like this. Okay, and how many hydrogen are there? So one hydrogen with all this oxygen. We will attach and we will get this. Got it? So this is the structure of H3PO4. Now there is a question that R3 N double bond O doesn't exist, but R3P double bond O exists. Why? Can you think of it? What it is? This R means alkyl group. So it says that if I am making like this doesn't exist, but if I am making like this, sorry, this is P, this exists. Tell me what will be the reason? Yes, of course, it is related with the pentavalency of phosphorus, or we can say that it can extend its octet due to the availability of d orbital. So as phosphorus can extend its valency due to availability of d orbitals. Got it? Hence it can show a pentavalency while nitrogen can't. Okay. Now there are some reaction of phosphorus with oxygen. So how the phosphorus react with oxygen? So P4, it reacts with oxygen. What it will give? It depends upon that with how many oxygen it is going to react. Okay. So like P4, if it is going to react with 3, so this will give you P4O6. If it is reacting with P4 plus 5O2, it will give you P4O10. Got it? Okay, so this P4O10, when it forms, it gives a white dense fume. And this is the reason, question can be asked that I will ask in next sheet, that what happens or why phosphorus when reacts with oxygen gives a white fumes. So actually when phosphorus reacts with oxygen, it gives P4O10, which is a white dense fume. Got it? So this is the reason due to this reaction. And there is again one question, why it is used in home signal. Like there is a signal which is used on the cargoes or ships where we use. So what it is used to give the signal that there is some problem, or in between the sea if there is any problem, or if they need any help. So they just throw the phosphorus ball in the air where it catches fire and it gives the white dense fume. So due to which we can, like the people who are in nearby, they can get this thing that there is someone which is in trouble or which is in problem, so they can come for the help. So that question I will ask, don't worry about that. Okay, so now there is a red phosphorus. We have to do all the allotropes. The one allotrop we have done, that white phosphorus. Now this is the second allotrop, red phosphorus. So let me read this, what it is. It can be obtained by heating white phosphorus at 573 Kelvin under high pressure. When the white phosphorus is heated at high pressure, it gives red phosphorus, and it is odorless. That means there is no smell, non-poisonous, and insoluble in both water as well as CS2. Neither it is soluble in water nor it is soluble in inorganic solvent like CS2. And it exists in a polymeric chain of white phosphorus. Exist in polymeric. See, in if you see that white phosphorus, there was a bond between these two also, isn't it? So now ye bond break, okay, and that is going to attach in the polymeric chain form. Clear? So, and this is the red phosphorus you have seen at home. Tell me where you have seen. Yes, in that matchbox, the side of the matchbox and all that, that is made up of red phosphorus. Got it? Okay, so now next thing is black phosphorus. So we are supposed to know that what is black phosphorus. Black phosphorus is again of two type. It is two form, alpha black phosphorus and beta black phosphorus. In this we will learn this black alpha beta phosphorus. This alpha beta phosphorus is formed by heating red phosphorus in sealed tube at high temperature, while the beta black phosphorus is prepared by heating white phosphorus. That means if we heat the red phosphorus in the sealed tube at high temperature, then it will give you alpha black phosphorus, and if that white phosphorus is heated in the sealed tube and at high temperature, high pressure, then it will give you black phosphorus. Got it here? So this is about the allotropes of phosphorus. Now we will do one compound, like this is phosphine we have to do, and another is phosphoric acid we have to do. So let's start with this phosphine. So phosphine, the formula of phosphine is pH 3, and this is the structural formula. How we will draw as like ammonia, we have to draw like this, and hybridization will be sp3, because we know that it is 1 2 3 bond pair and 1 lone pair, including this it will give you sp3. So now the preparation, same as ammonia we can do, like when metal phosphide undergoes hydrolysis, it forms phosphine. So as I told you that when the metal hydride go on, like when it undergoes hydrolysis, and if it is in the least state, oxidation number won't change. Okay, so you just check that here phosphorus is having -3 oxidation state, isn't it? So that means we have to write a product which is having -3 phosphorus. So these are the two products left. One is this and another is this. So phosphonium we will not prepare because it is positive charge, and again that there will be no like charge over here in the reactant side. So if we will put the pH 4 plus, it will be difficult to maintain the electrical neutrality, or we can say that the charge balancing will not be there. So we will form a neutral compound, that is pH 3. So one product is mass product, that is pH 3, and another, since this oxidation number has not changed, so obviously for the calcium also it shouldn't change. So calcium is here in +2 state, so it will react with this and it will form CaOH whole twice, where the calcium is also in the +2 state. Yes, so we can write that there is no oxidation reduction. So tell me, guess what will be the product in this case? Ca3P2 plus HCl. There is no water. So what will be the product? See, in previous class only I have told you that if acid is there on the reactant side, so acid behaves as an acid when until or unless it is when it is dissolved in water, isn't it? So if acid is there or base is there, it is indirectly water is that side. So if water is there, again there is the hydrolysis case, and then what will be the next product? So obviously this is -3, so this is the only product pH 3 to form, yes, isn't it? And what will happen with this calcium? Tell me, think of it and tell me what will form. Cl is left over here, calcium is left over here, so yes, it will form CaCl2, isn't it? This is the product. Now let's do some properties. Properties of phosphine. It is a colorless gas, having rotten egg smell, you know, and highly poisonous. This is highly poisonous, that you have to understand. And it is used in home signal, as I have described yesterday, earlier, yes, on that home signal. So which contains calcium phosphide and calcium carbide, when reacts with oxygen gives fire signal. See, जो home signal होता है, actually basically the phosphorus reacts with the oxygen, but वो phosphorus if we will keep in that form only, so what will happen? जहाँ रखा होगा वहीं पे वो burst हो सकता है, isn't it? So that's why this phosphorus is kept in form of calcium phosphide and calcium carbide. In these two form को वो mix करके रखा जाता है. So when we throw this in the air, it releases phosphorus, and that where it reacts with this oxygen and gives P4O6, and that is P4O10, and which gives the white dense fume. And before that it catches fire also to give this fume. Okay, so that works as a signal. Now if I am giving this reaction, see, if you can remember the equation with the ammonia, I have explained that ammonia with some D block element, yes, it forms a complex, isn't it? Like, let me show you. This is copper and ammonia, so it will form a complex. So accordingly you can think, so you will make the complex here instead of ammonia, you will keep this pH 3, and oxidation number is here 2. So what you will do, you will put a number over here which will be double of this and the charge over here like this. But I'm just telling you, this won't form. Ammonia can form but phosphine cannot. Ammonia act as a ligand. इसका ammonia का nitrogen that is smaller, lone pair is available, and it can form the coordinate bond with the metal. But phosphine cannot work as a ligand because of bigger size of phosphorus. So it doesn't form the ligand. So that's why it doesn't form the complex. समझ में आई बात? So what next? Water is there. Hydrolysis case. So hydrolysis case, that means oxidation number shouldn't change. So what will happen if oxidation number is not changing? This is Cu, metal is there. So what we will make? Metal phosphide, isn't it? So we can make Cu3P2. And what next? P have used, we have used copper, we have used H and sulfur oxygen. So you can make that H2SO4. Got it? So this is the no change in condition. कोई oxidation number change नहीं हुआ. In some books you can get the another product also. What can be the another product? See, if it is copper and phosphorus is phosphine is in -3 state, so we can see that copper is in maximum state and P is in minimum state. So that means there is a chance of oxidation reduction reaction. Okay, all the water is there, but it can, because both the things are there and they can form oxidized and reduced product also. So in some books you can get the product. So what next? If phosphine is -3, that means it has to be oxidized and copper has to be reduced. So very clear, copper if reduced, it will show only 0 state. So we can make copper 0, isn't it? And phosphorus has to be oxidized. So check the oxidized product. Like, so after that the stable one is P4, isn't it? I have explained. So that we will make P4 over here. P4. What happened with this sulfur SO2 and H2? Now oxidation and reduction already done. So there should not be another or further oxidation reduction. Because one reaction, one reduction, one oxidation already done. So what will happen? This H2 will combine with this and it will form as it is H2SO4. It will remain. So this can also you see somewhere. But if you are writing this one, there is no problem at all. Got it here? Okay, so this is, and then after we will do some questions. So let me write this question, and here I have written this question. What happens when pH3 reacts with HBr? Just think, decide क्या बन सकता है. So let me write the equation. pH3 plus HBr. This is a type of acid. We know that hydra acid, isn't it? If acid is there, so obviously there will be no there will be water, and water is there, that means it can be a case of hydrolysis. So if hydrolysis is there, that oxidation number will not change. So what can we form? क्या बना सकते हैं हम? Like अगर, if you can remember, you can think or you can relate. If NH3 and HCl are reacting, what it will form? Yes, it will form NH4Cl. So similarly you can combine this and you can form PH4Br, where there is no change in oxidation number. Or you can make like phosphine is there, so -3 state, either in the phosphonium ion or in the let me show you again. This is either in the phosphonium ion or in the what? Phosphide. So phosphide is not possible because metal is not there, isn't it? So if metal is not there, so only phosphonium ion is possible. So you can make PH4 plus, and if it is plus, so obviously this H has gone to this, so Br minus. So you can make like this. Okay. And the question can also be asked, this is the same question can be asked. Write a reaction in which proves the basic nature of phosphine. How can you prove this basic nature? Say HBr, we know that it is an hydra acid, and that also we know that with an acid, base will react. Two acids cannot react with each other, isn't it? So if it is acid, so obviously this will be base. So this proves the reaction. So hence it is a base. Got it? And it is a salt forming. Okay, so here is the next question, and the next question is bond angle in PH4 plus is higher than that of PH3. Why? अगर हम PH4 plus की बात करें, so this will be PH4 Yes, and this will be the pH3. So if you can relate and if you can think, there is the bond-bond relationship and there is lone pair bond relationship, isn't it? Or repulsion, you can say that. So here it is, in that lone pair is present. So due to this presence of lone pair, there is electronic repulsion between the bond pair and the lone pair. This is the lone pair and the bond pair. It will repel, due to which what will happen, this two hydrogen will come closer to each other. Got it? Because there will be repulsion. ये इधर repel करेगा, ये इधर repel करेगा, and this will come closer. So that's why its bond length will be what? Shorter. ये जो bond length होगा वो short हो जाएगा. But in this case, there is a bond pair repulsion, and we all know that lone pair bond pair repulsion is more than the bond pair repulsion, isn't it? So that's why here the contraction of bond will be more in comparison to this, and that's why its bond angle is higher than this. Got it? So let me write this. So class, here I have written this. Due to presence of lone pair in pH3, there is lone pair bond pair repulsion, due to which the H-pH bond angle in pH3 contracts, and hence it becomes less for you. So which I have explained right now. Okay. So now we are going to start with another compound of phosphorus, and that is phosphorus halide. Phosphorus halide. That means there will be a bond between phosphorus and the halogen. Out of that, two are main. That is PCl3 and PCl5. Lots of reaction we have done in organic also for this. So this we are going to study. So in this PCl3 and PCl5, there are the two type of phosphorus chloride. PCl3, if I will say, that is called phosphorus halide, and the structure will be like this. One will be the lone pair. Okay. If we have to prepare this, it can be prepared by P4 plus 6 Cl2. PCl3 will be prepared. This is white PP, white phosphorus. Now the question is, now there are the two things, and which is very similar, almost similar. If white phosphorus reacts with SoCl2, okay, it will give you PCl3. But if it reacts with SO2Cl2, it will give you PCl5. Got it? So this is very important thing. You can keep in your mind. Yes. So this will be, here it will be PCl3 plus, what next product will be there? Now, agar abhi yahan pe dekho, this is in 0 state, isn't it? And here it is making, it is in this +3 state, because chlorine is more electronegative than the phosphorus. So chlorine will have -1 and phosphorus will have +3. So what is happening here? This is oxidation occurring over here, isn't it? So that means there must be a reduction product also. Clear? Now check the oxidation number over here. In this, chlorine is in -1 state and oxygen is in -2 state. So this becomes -2, -2, -4. So obviously sulfur will be in the +4 state. So phosphorus has undergone oxidation. So obviously the sulfur has to be reduced. So sulfur on reduction, there is a product you have to learn for now, because this we will learn in group 16. Okay, so this will, and here is the oxidation number of sulfur is +1. Okay, so this is the reduction, and here one more product will form to balance this oxygen, and that will be SO2. But there will be no change in oxidation number with this sulfur. Here also it is +4, here it is also +4. There is no change in that. Okay. So this is the product formed when phosphorus react with SoCl2. What will happen when phosphorus react with SO2Cl2? It forms PCl5. Okay. So PCl5, here it is +5, here it is 0. That means oxidation is being done. Now what left? Reduction. So sulfur thionyl chloride has to reduce. So this will reduce in form of Cl is used, SO2 it will form simply. So here you can check, this is +4 state, isn't it? Sulfur is in +4 state, and here it is in +6 state, because -1 chlorine and -2 oxygen. So 2 2s are 4 and 2 6. So obviously sulfur. Got it? So this is the reaction that you have to learn. Now we have done in organic also, we have done how this PCl5 reacts with the compound. Yes, so let's do that one. So if you talk about the chemical reaction of PCl3 and PCl5, so this is PCl3 and PCl5, how it reacts. So I have given you the trick how to like how it will react. So see what you have to do. This is C2H5O and H. PCl3 you have to write like this, PCl3 in center along with this oxygen, and then Cl here, and just break all this bond and it will give you the different compound. Okay, so that means whenever this PCl5 reacts, it will give you POCl3. That product will be for sure, I have explained in the organic, and you can check that there is again the case of no oxidation number change. So that's why POCl3 will form as a side product, because POCl3 oxygen, you just check, it is -3, -2, +5. The oxidation number should be +5. Here also it is +5. So oxidation number किसी का change नहीं होगा. What will be the next product? C2H5 we made Cl, and here it will be HCl. Got it? So now, अब ये बताओ what will be this product? If PCl5 is going to react with H2O, what will be the product formed? Yes, because oxidation number won't change. So what is the product? This is right now we made. It will be POCl3. Now think of it and tell me what will be the product form in this PCl5 and CH3CHO, how it will react. So see, the same way as I told you, CH3, C double bond O and H. Can I write like this? Yes. So make it PCl3, Cl and Cl like this. So our target will be that we have to take out the POCl3. अब POCl3 अब जैसे भी निकालना निकाल लो. It doesn't mean कि यहाँ पे दो बॉन्ड तोड़ना पड़ेगा. It doesn't mean. Okay. So if I'm taking POCl3 out from here, so there will be two bond free. So with one bond it will attach to this chlorine and one bond with this chlorine. So there will be no HCl in this case. Everybody क्या करेंगे बच्चे? In general HCl बना देते हैं. तो HCl will not form. Got it? So this will be CHCl2 plus, we can write POCl3, and how I have explained. Now next thing, if PCl3 is there, PCl5 with this, and I have explained in that class 12th organic that if PCl5 reacts it will form POCl3, and if PCl3 reacts it form H3PO3. The condition, the concept is same, that oxidation number won't change. So oxidation number is here +3 and here is +3. Got it? So you just check phosphorus in +3 state, what compound we have made. Yes, so by this way you can tell like this, H3PO3, this is compound. Okay, so what next? This will form C2H5 Cl. Now few questions on this, and then this phosphorus will over. So question is that when POCl3 reacts with excess of water, POCl3 excess of water, water is there, hydrolysis case is there, oxidation number will not change. So we have to make a compound which is having +5 oxidation state, as phosphorus is here in +5 state. So +5 के लिए हमारे पास these are the compounds, isn't it? These are ionic, negative charged हैं. So we cannot make charge because it is not charged on there is no charge on the reactant side, so we will not make this charged. Done, khatam. So we have option this two, H3PO4 or P4O10. So if we will make P4O10, where will this HCl will go? So either if you want to make this P4O10, you can make, no problem. And this H and Cl will form a compound. This is also correct. And or you can write in another way, you can write this one H3PO4. So you can write in this form H3PO4, and where the next will form HCl will form. Yes, so you can write in this way also. There is no problem at all. Got it? Hope there is no problem. Yes. Now what will happen if PCl3 is heated? अगर हम PCl3 को heat कर रहे हैं then क्या बनेगा? So heat करने पे we know that in class 10th we have done there will be dissociation reaction, isn't it? Dissociate हो जाएगा, decompose हो जाता है. So if it undergoes decompose, so here it is +5 and this will decompose. यहाँ देखो दोनों ही reductant होंगे. This is PCl3 and another will be Cl2. So now it is a different type of reaction. ठीक है? The same element undergoes what we say, dissociation, and with the two different oxidation state. This is +3 and this is 0. So this is, you can learn this equation. ये equation आप समझ सकते हो, learn कर सकते हो. Got it? Okay. Next question is, are all the 5 PCl bond in PCl5 equal? So just find the PCl5 hybridization. PCl5 hybridization, if you will find, you will get this sp3d, isn't it? And if it is sp3d, we have the structure like this, trigonal bipyramidal, in which there are the chlorine, 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 and chlorine and chlorine, isn't it? So these three bonds, ye, and ye, these three bonds are axial bond. So they are same. And this one and this one are called equatorial bond. Sorry, these are axial bond and axial bond. And this one is known as equatorial bond. So bond angle is not same. Yes, no, all the five PCl bonds are not same. Why? As 2 are axial and 3 are equatorial. Got it here? Okay, so next question is, in which form PCl5 exists as in solid state? Solid state में PCl5, ये that is also you have to learn. There is no concept in this. Actually coordination का concept है, but अभी बहुत दूर है, so we have to learn this. So PCl5 होता है जो it exists in solid state form में, it exists as a complex. Let me write, exist as a complex. And complex कैसे बनाएगा? It will give you PCl4 plus and PCl6 minus. That oxidation number will be same in both the case. Here also +4, +5, here also +5. So this is called pentachloride phosphorus and hexachloride phosphorus 5. ये लिखा जाता है इसके लिए name. Will tell you, I will explain how to write the name in coordination chemistry. Don't worry about that. Chali. So next question, let's move to next question. What happens when PCl3 reacts with moisture? What will happen? Or question can also be asked in another way. Why PCl3 gives fume in moisture? So when this PCl3 reacts with moisture, H2O, this will form. We have done the equation. Tell me, we haven't formed. Okay, so see what will happen. This is +3 state, so we'll make +3 state compound, and that is the H3PO3, isn't it? So since there is no oxidation reduction, so obviously the Cl should remain in HCl form, and this HCl gives the fumes. This gives the fumes. Okay, so due to this HCl formation, there is a fume in the moisture when this PCl3 reacts with the moisture. Got it? Now these are the last question of 15th group. We will start 16th group now onward. So it is question is that what happens when H3PO3 is heated? Again I told you, whenever the compound is there and heating, there will be decomposition. So decompose to hoga, but there is a difference in these two compounds. In that, if I will show you, PCl5 was in the maximum state. That means it was not having a chance to reduce or oxidize. इसके पास सिर्फ एक ही चांस था कि ये reduce ही हो सकता था. Got it? That's why it undergoes under dissociation हो गए दो different compound में. Got it? Here in this case, if we check H3PO3, it is in the +3 state. That means it has chance to oxidize as well as reduce. So when this will heat, this will be heated. It will give you the oxidized as well as the reduced product. So what we have to write? We have to just simply see the most stable, this one is the state, the most stable oxidized state H3PO4, and the most stable reduced state is PS3. We will make. So this is what will happen. It will form H3PO4 and PH3. So here it is +5 oxidized, and here it is -3 reduced. Got it? Okay, and the last question, last reaction. What happens when silver nitrate reacts with hypophosphorus acid? Silver nitrate formula you all know. It is AgNO3, isn't it? And hypophosphorus acid is H3PO2. Solution की बात करते हैं हमेशा. So this will be water we will take and H3PO2 we will take. Now, let me write here silver nitrate solution. So think of it. यहाँ पे क्या है? Water is there. So oxidation number shouldn't change. But ध्यान दीजिए यहाँ पे. This is in +1 state and this one is in +1 state. मतलब it is in the between stage. It is in between. Got it? I told you hydrolysis we will follow that concept when it is in the maximum or in the least one. But if it is in between, it will undergo oxidation and reduction. So this is H3PO2. That means it has here if we see that H3PO2, this one. So this can go in this way also. मतलब oxidize भी हो सकता है, reduce भी हो सकता है. But AgNO3 is in +1 state. That means it is in the maximum state. इसके पास सिर्फ एक option है, that is to be reduced. So it will reduce in Ag like this. It will reduce. And if it undergoes reduction, that means for sure H3PO2 has to be oxidized. So this will be oxidized, and the most important or the stable product is after this H3PO4 it will form. Got it? H3PO4 will form by this oxidation. So what happened with this NO? Now oxidation reduction is done. So no further oxidation reduction should be there. अब और reduction oxidation नहीं हो सकता because one reduction अगर एक और oxidation होता तो there must be some other reduction should also be there. Got it? To equate it. So that's why this nitrogen oxidation number shouldn't change. So what it will form? N and water will combine together to form HNO3 where nitrogen is in +5 state, no change in oxidation state. Got it? So that's it for group 15. And now group 16 we will start in next class. So till then, thank you class.